Good morning, world. Paul Whittekind back with the universal law of numbers. And the first thing I'd like to do is apologize because yesterday I said something that was a little bit stupid and incorrect, which I've done a couple of times. I added up something in one video when it was 24 in actuality, and I said it was 22, but the point that I was making was not affected. Yesterday I spoke about 7, 8, 4, and 7, 2, 9 as perfect squares, which they are. However, I call them the square of 28 and the square of 29, which in reality 729 is the square of 27 and 784 is the square of 28. And I tried to make a little sense of that, which I probably failed to do somewhat. But one thing I can bring to our attention is that 729, we see that reduces to a 9. And 784, 7 and 8, 15 plus 4 is 19, and it reduces to a 1. And I think at least that is saying something to us. And I want to kind of reiterate really the main points that I'm trying to make here, which are, okay, so the table, we know that it's a circle based on a 369 code, and it repeats itself. So it's an ongoing repetitive cycle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and all of the other aspects of it are a repeating revolving circle as well, because if we take a square to the 7th power, or a number and take it to the 7th power, once we hit 7, it will return again to just the way it was when we square the number and continue on from there and revolve around in a circle. But the point that I'm trying to make is that the numbers repeat themselves in another way also. Well, how do they do that? Well, we see the 248751 code, okay, 248751, and we see the other codes 2714, 417, 818, and if we look inside the 25871 code, we're going to get, if we skip a number, we get the 285 code. So it's going to repeat itself. So look over here and we'll kind of like just look at the first two numbers and we'll add them. 5, 9, 8, 6, 2, 3. And if we, well, I will do that for us. 5, skip, 8, skip, 2, skip, 5, skip, 8, skip 2. Okay, so it's repeating itself in that way as well. The 248751 code, well, it repeats itself as well, doesn't it? Because it's over here, 248751. The 714, it repeats itself as well. It says 714 again. 417 repeats itself again. 417. It's like somebody talking to you and they're repeating themselves. And the reason people do that is because they're trying to get a message across. And all they're doing is repeating themselves to try and get the message across. So I think the universal law of numbers is attempting to do something in that fashion too. And if we look at it going across, not only downwards, we'll see that it's constantly repeating itself as well. And once we apply codes upon codes and do the matrices, we see that it's repeating itself over and over and over. And the message is bound to get through. So, well, what does it all mean? Now, that's another question. Well, it doesn't mean anything at all to anyone who it doesn't mean anything at all to. But some things, they don't appear to mean much of anything, but they mean a great deal. So I'll just take this here and we have the number line. Okay, so we could always go and take an entire lifetime to prove it and just start writing on a piece of paper 1, 2, 3, 4, 5, 6, 7, 8, 9, and just go on forever, and they're never going to reach infinity. Or we can just do this number line, and that says everything for us. And the same thing applies going in the negative direction. If somebody wants to start writing on a piece of paper and spend their entire life writing -1, -2, -3, -4, -5, and on and on and on, and never reach infinity, that would be futile as well. So what we have in science and mathematics is we have simplifications that will explain a principle or a law in a very simplified form. Okay, so in physics, for instance, Newton came up with the F equals ma, and everything in physics is based upon that very simple equation. And everything is derivations of that equation, and then along came Einstein, and he came up with the E equals mc squared, which is in fact F equals ma all over again, at the speed of light. And we try and understand all of these principles. So I will, today we're going to, because I've alluded to the fact that it's a circle, my universal law of numbers. So I wrote a circle here for us. And interestingly enough, a circle is also the symbol for 0. So one of the things that I've pointed out in another one of my presentations is that we can use this universal law of numbers in all facets of learning, even in literature. And one of these days I'm going to do a presentation on that, but just to bring it, to highlight what I'm saying. So the circle is a 0, and 0, Shakespeare says, to be or not to be. So that's the question. So this is a question, in mathematics as well. I mean, it's a very profound question. It's not easily understood or easily explained. But of course, we do have a place for 0, as well as a place for the circle, because the circle, in effect, is also 1 through 9. It's a 9 or a 3, 6, 9 system. So quite simply, I can put this up to illustrate that, and we have a circle divided into 9 parts. And from that, you can also take a circle and you'll get your first triangle. And that's how the circle and the universal law of numbers becomes geometry as well. So if we turn this circle into a trigonometric circle, then all of a sudden it turns into trigonometry as well. If we start doing calculations in 3 dimensions with all of the forms, well, that turns into calculus also. So the point that I'm trying to make here is one that I made earlier. I made the statement that all mathematics, when it boils down to it, it's basically arithmetic. And if we want to go take that even further, we can literally say that it's just counting. So arithmetic is counting. Counting, and then we call it arithmetic, and then we call it algebra, and then we call it geometry, and then we call it calculus, and we call it differential equations, and we call it linear algebra. But in reality, it's all just arithmetic and even counting. Now, when we go to a university and we look at the syllabus and the courses that are being offered, well, you're going to see all of those types of courses, calculus 1, 2, and 3, and maybe algebra courses, and, all kinds of exotic courses in mathematics. and number theory, etc. But in reality, it's all just counting, it's all just arithmetic. And this, just like F equals MA or E equals MC squared or the number line or turning the number line into a circle, because that's what it is. It's revolving. It revolves around the numbers 1 through 9. And we do put zeros at the end of numbers, and we understand why we do that, because there is a difference between a 10 and a 1. However, it's just a 1 changing its personality going to the next power. Because if we take 1 and we square it, we get 1, and we cube it, we get 1, and no matter how many times we multiply it by itself, it's always going to be a 1, and that's exactly what happens here in the universal law of numbers. So for atomic physics, it's applicable. For any kind of creativity, whether it's in art or music, it's applicable. And it's applicable on every level, because if you have children and they're 3 or 4 or 5 years old and they've already learned how to count to 9 or 10, you can take this code right here and you can draw up your own matrices using the different codes within the code, and just have the child, color by numbers. And in so doing, that child, through osmosis, will learn a great deal about how numbers work and how numbers fall into place in the universe of numbers. And I highly recommend you do that. And compared to these video games and all of these things that, in my mind, pollute the children's mind, violence or whatever, that's not what they should be learning. They should be learning the laws of nature and the laws of the universe, and that's just a point I would like to bring to people's attention today. So today was a very easy lesson, and we will continue on with the same thing as we go along, but the whole idea is simplification. Taking the whole universe of numbers, simplifying it into this very code, which is, 54 numbers. If we go 6 down and 9 across, that's 54. If you want to include the 1, 2, 3, 4, 5, 6, 7, 8, 9, then you're up to 63 numbers. But just 63 numbers in this arrangement describes mathematics and the world of numbers that we live in. So have a happy day, peace to everyone, and I hope to see you again next time.